I'm Casey Green with the Campus Computing Project. We're here in Las Vegas at the Consumer Electronics Show, and specifically the TransformingEDU Forum. And I'm speaking with Anant Agarwal, who is a professor at MIT and also the president of EDX. Welcome.
Thank you, my pleasure.
So, Anant, you did a keynote presentation earlier this morning talking about the experience of MOOCs and particularly some interesting things about EDX. There's been a lot of conversation about MOOCs over the past 24 months. Some see them as the great potential for higher education, others that see them as the end of the high-touch academic experience as we know it. Lots of different points in between. Many governors and policymakers view MOOCs as a way to kind of deal with some of the cost issues. I want to sort of put the conversation about MOOCs in a different context in terms of the evolution of technology. MOOCs are, for all practical purposes, in terms of the effort at EDX, Coursera, Udacity, some others, 18 months, 2 years old, you're developing new platforms, they're evolving. Is it fair to say that where we are in sort of the cycle of MOOCs is kind of like where we're with DOS and personal computers in 1982 with the IBM PC, DOS 1.0?
Absolutely. I like to use the example that we are at DOS 1.0, but I like to say we are at where cell phone technology, mobile technology was at in 1987, 1988, where you had this big honking piece of hardware screwed down to the bottom of your car. And look where we are today, 20 years later.
Yeah, and so let's use that same model, that the fusion of innovation. So we know, for example, that with cell phones, early adopters had resources. You know, they were expensive. Somebody else paid for it. I think that there's a parallel to that. I think we look at some of the data about who's not so much who's registering for MOOCs. The numbers are massive, but the people who complete, more often than not, they've already had prior college experience, may have a graduate or a master's degree or a baccalaureate degree. When do we get beyond that first tier? You know, when, for example, in terms of thinking about the goals that EDX has for access, talking about making content available freely, being able to certify it, these will be certifiable certificates. When do we get to the point where the MOOC is more generally available and more appropriate? Not for the person with a graduate degree who wants to expand his or her portfolio, but a person with no degree, minimal background or prerequisite training to go into not a generic MOOC about zombies, which can be kind of an edutainment, but into the kind of the high value,
and so on.
The high value STEM courses that are so badly needed in all cultures and all countries and for all economies.
Absolutely. I think just as with all technologies, you have the early adopters.
Right.
And the early adopters might be, depending on the technology, might be geeks or high risk takers.
Yeah.
And certainly in the case of MOOCs, people that on the edX platform, for example, about 55 to 60% of our learners have a bachelor's degree. But remember, 40% of learners do not have a bachelor's degree.
Right.
So that's a sizable number when you're talking about the 1.7 million learners on the edX platform. So, 40% of learners do not have such a degree.
Right,
but over time,
if I may, but by conventional metrics, and unfortunately you're stuck with conventional metrics, when people ask you about retention rates, the reality is the 60% with degrees are more likely to make it through those courses than the 40% who don't have a degree or the technical background, particularly for those STEM courses. You teach computer science, artificial languages. I mean, there's courses in big data. There's great value in the humanities, and many would argue there's even higher value in the STEM inventory.
So without arguing where the high value is,
Yeah.
I mean the point is that as we create these courses, we certainly want to get to a phase beyond the DOS 1.0 stage, where we want to get to V6, V7, where the smartphone is today. Mm-hmm. And so there are a number of technologies that we have to develop, and then different kinds of content we have to develop. Let's take content. So I taught with my colleagues a course on circuits and electronics, which required prerequisites in advanced physics and advanced differential equations. Still, 5% of the learners passed the course. But that said, we don't still have a course on advanced calculus.
Right.
We do have a course on advanced physics. So now as we create more and more of the prerequisite courses, reaching into high schools, we just announced with the College Board and Davidson College AP course modules. So as we create more and more background courses, we now expand the funnel, open up the funnel, so more people can take and learners can take the background high school level courses, which will then prepare them for the harder college level courses. So that's one big thing that is happening in terms of content. It will take a while to get there. In terms of technologies, we're also developing technologies to enable people to do much better at these courses. One of them is the blended model of learning, where we are combining in-person technologies with online technologies and bring the best of both worlds on campuses and outside. Second is researchers on the edX platform, as they mine the data, are finding that students who work together with other students in groups are doing much better than those that work themselves.
No question. And there's a long and a very rich research history about
Absolutely.
collaboration.
Absolutely.
You know, that students across all
And so
cultures
we're
and all
looking at a
contexts.
number of ways in which we can advance these technologies, bring them onto the platform. So for example, on edX, we implemented, as part of a discussion forum, the concept of cohorts. Cohorts is a way of creating smaller discussion forums.
Make things sticky.
Make things sticky, make the forum smaller so you have smaller groups. And these will keep getting added on, and just wait till version 7.
Yeah. So one of the comments that you had this morning, a young woman stood up and asked about TAs, taking the experience common at many large institutions and trying to transfer it to the MOOC environments. There was a very compelling article in the New Yorker last year, Laptop U, talking about the development of MOOC courses and focusing very explicitly on a Harvard professor who teaches classics, the mythology course. Long part of the canon, he's been there for 3-4 decades. He really looks like a classic Harvard professor teaching classics when you see the picture. And the transformative experience he had, taking what in the past might have been, was, a lecture hall course perhaps enhanced with slides.
And transform it into
And transforming it into a MOOC. One of the most interesting parts of that was not the de-chunking, if you will, small video segments, but in fact, several sources reported, he sent out a call to former students, would you be willing to be a TA? You know, the instructional infrastructure that acts as a formal analog, not an ad hoc analog, to office hours and the collaboration and the kinds of, where is the instructional infrastructure for this, as opposed to me slogging it alone just by myself on the other side of the screen. Where is EDX going with that organizationally?
You know, it relates to crowdsourcing. And what is really interesting, the meta point here is very interesting, which is that if you look at technologies today, technology with big data and with crowdsourcing has discovered that large groups of humans can be very powerful if we can focus their efforts on something. On our platform, we can anoint them as a community TA, and it's almost like a badge of honor. And together, these students work and help other students learn. So this becomes a crowdsourced way or a peer learning approach to helping other students learn. And I think this is completely fair game. When you have large groups of students helping each other and working together, and really using the community to help each other, that's a really good way to do peer learning, where people learn as they teach as well.
All right, last question, if I may. You showed some very interesting data earlier today. EDX, Coursera, Udacity, you're all collecting literally massive amounts of keystroke and other kinds of data about the experiences of students. I heard Andrew Chegnak not long ago talk about the difference between teaching his AI course with 200 students, and if 4 students get a question wrong, that's rounding error and that's a student issue. You teach it with 100,000 and 2,000 get it wrong. The percentage is the same, but all of a sudden you've got a blip that you can begin to disaggregate and understand. It seems to me that one of the real likely benefits that's going to emerge from the MOOC experience is again, a kind of a point and a model of the continuum of online learning, is the massive amounts of data that you will have access to in terms of understanding this. And what seems to be a very clear commitment on the part of leadership of these 3 organizations and others to go public with that data. People may not be very happy with the way some of that's done. We see some efforts on the part of Coursera, I think, is to kind of take that data and redefine retention rates on the basis of motivation. That may not fly in the way that most campuses work, but talk about some of the data plans that you have for the data that you're collecting at Coursera, as how that feeds back to what you're doing and comes back to a larger community.
So, so the way, I like to call our edX platform a particle accelerator for learning. We're grabbing huge amounts of data, every mouse click, all of the data from the students, and we share the data with our partners. So all our university partners are analyzing the data and to learn how students learn. And what you can do with this big data analysis is when you aggregate large amounts of data, even if you have a weak signal within there, by the powers of analysis and statistics, you can get out signals even though there's a large amount of noise. And I'll give you one example where researchers at Harvard and MIT were able to tease out the fact that when students spend more time doing homeworks, they would do better in a course. They were able to get that result. They found another result. Students that spent time working together did better in a course overall than students that worked alone. And so many of these...
But that shouldn't be surprising.
So many parts of these are not surprising, but my teenage son, for example, this is very surprising to him. He's always told me that homeworks are useless. But here we now have hard data that we can show our students that doing homework is a good thing. I'm just using that as an example. There are innumerable things where we have no idea whether something is not good or good. And we can now use rigorous analysis and statistical analysis using this big data. And we are committed to sharing the data with all our partners. And as we speak, they're analyzing the data and mining the big data to understand how students learn so they can improve the whole learning process.
Great. Thanks very much for your time today.
Thank you. Thank you very much.
Thank you.